In this video, I'll show you how to do transformations for the response variable and the predictor variable in our multiple linear regression analysis. So this is the real estate air conditioning example. And in a previous lesson, we fit a model with sale price as the response variable and square feet as one predictor, and the indicator variable air for a second predictor. And air is 1 if has air conditioning and 0 if it doesn't. And we're going to fit this model here, which includes an interaction between square feet and air. So one way to do that is to click the model button. And then if I select both predictors, square feet and air, so I do that by pressing either the shift key or the control key on my keyboard as I click on air. And then I can do interaction through order 2. If I add that, just take a look what happens down here. So I'll click add, and then we get square feet times air down here. And then I'm going to save the fitted values and the residuals. Okay, so there's the model, and in our spreadsheet, we have fitted values and residuals. So let's do a quick residual analysis to see if the assumptions, the line assumptions seem reasonable for this model. So I'm going to do a scatter plot with residuals on the vertical axis and fitted values on the horizontal axis. Okay, and we can immediately see that there's a problem with equivariance. Okay, the reason I can see that is because if I imagine slicing this graph in vertical slices like this, actually let me do that literally. So if I use lines, okay. So I'm doing this for illustrative purposes. In practice, there's no need to draw these lines on. It's a nice visual aid when you're learning about this topic for me to do this literally. But in practice, you can kind of, with experience, you can eyeball this without having to actually draw these slices. But the idea is, so in this slice, I'm looking at the variability of the residuals. Okay, so you can see that the residuals in this slice are not very variable. They're going from up here down to here. So the variation is pretty narrow. Okay, in the next slice, it's widened quite a bit, especially if you think about this point up here. Admittedly, that's just one point, but even without that point, there's a wider variation here than there was in the first slice. And then in the third slice, now I've got a lot of variation all the way from down here, all the way up here. Okay, so the variance of the residuals is not equal for fixed values on the horizontal axis. Okay, and that's one of the conditions. That's the E condition, or the E assumption for a multiple linear regression model, is that the variance should be the same in all of these slices. And you can keep going. The variation's still quite wide here. It's possibly even wider here. It's still pretty wide here. And then maybe a little narrower here. But it's unequal all the way across. So the E assumption is not valid. That means we can't really rely on this model. So we need to improve the model somehow, come up with a better model that will satisfy the line assumptions. Okay, so let's do that. So I'm just gonna minimize that graph. I'm gonna leave these lines on here just because I'm gonna do another residual plot for the next model, and it'll be helpful to have these lines still in place. Okay, so what we're gonna try here is to take the natural logarithm of the sale price and the natural logarithm of the square footage. Why might I do that? Well, let's just take a quick look at histograms for each of those variables. So let's do sale price first. Okay, we can see that it's skewed. Okay, the bulk of the sale prices are kind of down in this range down here, 150 to 300. And then there's far fewer up in this upper range, 750 to 900. Okay, this distribution is skewed. Again, often with skewed variables like this, taking the natural logarithm will make this more kind of bell-shaped and more symmetric. And often doing that will lead to better models. Let's do a similar thing for square feet. And same kind of thing. Not quite as skewed as sale price was, but still pretty skewed. Okay, the bulk of the data is down here, and then there's very few really big houses, as we might expect. Okay, so I need to calculate those transformations. So let's do the response variable first. So that was the natural log of, so what I do is I type in ln for natural log, put a bracket, double click sale price, close the bracket, and boom, there we go. And then I'll do the same thing for square feet. Oops. Square feet, and there we go. Oh, what happened there? Syntax is all wrong. Okay, so we can see in our spreadsheet, we've got log y and log x. And let's just confirm by looking at histograms whether we did make those variables more symmetric. So here's the sale price one. And yeah, there's definitely more symmetric than it was. It is not perfect. We're not expecting perfection here, but it's definitely more symmetric. And then let's look at square feet. Okay, much more symmetric than it was before. Okay, that's not necessarily going to fix the problems with the model, but it often turns out that way. So now let's fit a regression model. And this time I'm going to use log sale price, and I'm not going to use square feet. I'm going to use log square feet. And again, I'm going to put the interaction into the model. Okay, and again, I'll save the residuals and the fitted values so we can take a look at the residual plot. Okay, there's the analysis of variance table for my model, but what I want to do first is just take a look at the residual plot. So this time it's going to be the most recent residuals the model calculated, and it does resi underscore and then 1. If I was to fit another model, it would be resi underscore 2 and so on. So this is the one for the residuals that were just resulting from the last model fit, and then fits 1. Okay, and then let's just square that up with my slicing lines. Okay, and if we do what we did before, think about the variation within each slice. Don't worry about this slice over here. There's only 2 points there. Okay, so there's not a lot of information there. The variation is from down here to up here for this one. little bit wider here, a little bit wider. But overall, if we just kind of think kind of big picture, don't get hung up on tiny little details, but big picture, the variation within each slice is approximately equal. Okay, it's never going to be exactly the same, but this is pretty good. From experience looking at these residual plots, many of these over a long time, this is pretty good. Okay, the variation within each slice, it's good enough for me to be able to say with a pretty high degree of confidence that the equal variance assumption for this model is probably okay. And it's certainly an improvement on the previous model. On the previous model, remember, we had very little variation in these slices, getting bigger, getting really big. Okay, this one, it's fairly consistent all the way across. So equal variance is reasonable here. One last thing I'm going to show is, you might be wondering how to get this graph here, because this graph was actually created in different software, not Minitab, but we can actually create this in Minitab. So if I go to graph scatter plot, only this time I'm going to do with regression and groups, and then okay that, and then I'm going to have log y on the y-axis, log x on the x-axis, and then I'm going to have air in here for the categorical variable. Okay, and I'll show this down here. So actually, let me get rid of some of those lines so they're not going to be distracting us. There we go. And I'll move it, oops, I'll move this guy up here now. Okay, actually, let me maximize it. All right, so there we can see that we've essentially got a straight line fit to each type of house. The blue ones, air is 0, so those don't have air conditioning. Sale price is a little bit lower for a fixed value of the natural logarithm of square feet. And then the air-conditioned houses are the red ones, okay, and they have higher sale prices. And the red line, it's steeper than the blue line. So in other words, the price increase per square foot is a little bit higher for the air-conditioned houses than the non-air-conditioned houses. Okay. One last thing I'm going to show you as well is this graph, because of the plotting symbol that Minitab is using by default here, it's a little bit hard to see what's going on in here. So one thing you can do is you can change those plotting symbols. If I just click on, I need to show you where I'm pointing. Okay, if I click on one of these points, okay, they all get highlighted. But if I just click again, then just the red ones are highlighted. And then I'm going to double click. And then now I can change the plotting symbol, and let me make it an open square instead of a filled square. Okay, and then I'll do the same thing for the blue ones. Make it an open circle. There we go. Oh, that didn't work. I just selected one. Let me try again. Let's try it again. I think I got all the blue ones this time. There we go. Yeah. Okay, so it's perhaps a little bit cleaner. Anyway, that illustrates how to apply transformations to both the response variable and the predictor variable in a multiple linear regression analysis.